Understand chemical equations. Chemical reactions. In chemical reactions, existing substances combine to form new substances. The substances that combine are reactants. The substances formed are products. Energy may be absorbed, endothermic reaction, or released, exothermic reaction, during a chemical reaction. New substances are produced during chemical reactions because the atoms making up the reactants bond in new ways. This change in the ways the atoms bond changes the chemical characteristics of the matter involved. Many substances react chemically with each other to form new substances. For example, many elements react to produce compounds. Many compounds react to produce other compounds. A chemical reaction can be represented in the following ways. Words: magnesium plus oxygen, rightward arrow, magnesium oxide. Symbols: 2 mg plus O, rightward arrow, 2 MgO2. Models: visual representation of atoms. Law of conservation of mass and balanced chemical equations. During a chemical reaction, the arrangement of atoms in the matter involved changes. However, the total number of each type of atom does not change. This scientific concept is the law of conservation of mass. A balanced chemical equation reflects the law of conservation of mass and provides accurate quantitative information about a chemical reaction. It tells not only the way that atoms are rearranged during the reaction but also the relative amounts of the substances that make up the reactants and products. An equation is balanced when the number of atoms of each type on one side equals the number of atoms of each type on the other side. The diagram identifies the parts of a balanced chemical equation. The equation represents the reaction of methane, CH4, and oxygen, O2, to produce carbon dioxide, CO2, and water, HO2. Diagram labels for equation. Element symbol identifies element. State symbol indicates state of substance. Directional arrow indicates direction of reaction. Subscript indicates number of atoms of a particular element. Coefficient indicates ratio of reactant or product. Reactants indicated by green square. Products indicated by orange square. Types of reactions. Different types of chemical reactions occur. In synthesis, two or more reactants combine to form a single product. The general form equation for this reaction type is A plus B, rightward arrow ab. In decomposition, a single reactant forms two or more products of rightward arrow A plus B. In single displacement, one element replaces another in a compound of plus C, rightward arrow AC plus B. In double displacement, two reactants form two new products of plus CD, rightward arrow AD plus CB. Limiting reactants. Depending on the amount of each reactant involved in a chemical reaction, a limiting reactant can exist. A limiting reactant limits the amount of product that can be formed because the reaction stops when all the limiting reactant is consumed. Consider the equation that represents the reaction of benzene, CH6, and oxygen, O2, to produce carbon dioxide, CO2, and water, HO2. As with any reaction, the reaction represented by the equation can be limited, depending on the amounts of certain substances involved.